Yeah, let's do that. Sorry, I was setting up. Okay. All right, guys. So welcome back. So we I said, yeah, took last week off, and actually one of the things I was supposed to do and did not get to it was I wanted to see about the scheduling for the presentations. I lost my document. I lost my document where I was keeping track of weeks and stuff. Let's see. So I printed out a new one, but let's see. 1, 2, 3, 4, 5. Okay. All right. So what we're going to do. A few of you I'm still waiting on you guys to tell me which of the two papers is going to be your longer paper and which one is going to be the shorter one. And remember, the longer paper comes with a presentation. So whichever one you choose to be the longer one, you have longer to write it. All right. It doesn't have to be submitted until the time of the final exam period. But I do want a presentation. So, even if you're not done writing it yet, you'll still need to give a presentation. What I'd like to do for the presentations is for anyone that's going to make the longer paper and presentation be your research. Those will come first. Because I think for some of you, based on who is choosing to do the longer paper as the literature review, it's some of you who have already started your thesis, or for many of you, it's some who have already completed the master's program, and so you already have your master's thesis done. And so for those of you who want to make the longer paper your literature review, I'm going to have you present first, since it's something that you've already kind of done and already been prepared, and hopefully have already practiced presenting that information anyway, or at least forms of it. For those of you who choose the longer ethical paper, you guys will come second. You guys will come later in the semester, especially because some of you have requested to kind of go together with the person who took the other side of your argument. So you took the pro and they took the con, you took the affirmative, they took the negative, and you guys want to kind of present together in the form of a debate. Which I think is a great idea. So what I'll do is I'll give you guys a little bit longer to prepare that, and so you will go as the second group. All right, but how I schedule that out and how many weeks are dedicated to each of those types of presentations will be entirely dependent on how many of you choose one or the other. Okay, so if you have not already done that on the Microsoft form, which I emailed some of you today about that, or yesterday, sometimes I can't remember when I did what. It just comes with old age. There's a saying, they say that memory is the second thing to go, but I forget what the first is. So anyway, go ahead and fill out the form. Choose, for some of you who did not choose a topic yet for your ethical argument, please do that. There's a few of you who have not done that yet either, and I need to go ahead and get that going. All right, so all right. So today, for the first part, we're going to talk about the idea of data analysis. Now, I realize that, and I can go ahead and share the slides that are available. I kind of really didn't do a lot in terms of the slides for this, because the text seems to be, come back to here. The text seems to be really heavy on what's it called? On like the type of data collection that would be for not necessarily an experimental type of research, but more of kind of forms, surveys, kind of what you might see in what's the word I'm thinking of? like I said, memory just starts going. The kind of maybe even like a medical research where you're testing based on responses. Now, in some ways, experimental research is in the same. There are some similarities there, right? Because take, for example, maybe what they're talking about in terms of these surveys is you you give somebody a survey for how they responded to some input, and it could be a mental thing, it could be a medical thing based on how their bodies have responded to certain types of treatment and stuff like that. In some ways, an experimental research can also have some similarities to that, in that instead of asking the thing being studied how it feels, we test for certain reactions. We test for certain responses, right? And the thing is once we collect all this data, once we get all this information, you'll have like tons and tons of information that then needs to be processed, that we need to put it into a form that we can understand it, that we can make conclusions, and that we can get results from. Because ultimately what we're trying to do is we're trying to prove or disprove a hypothesis in a lot of these situations. All right. So for the examples that we've talked about so far in this class with some of you in your own research, like I'm going to pick on, let's say, like Erdinch with the audio. I'm trying to remember. It's like something about audio and taking a second microphone, right? Taking a second microphone and to filter out or to try to reduce noise or something, right?
That's right.
Yeah. So you had a hypothesis and you did some experimentation to try to see if your hypothesis was, correct or false. And what would you have done? So how did you process through some of that data? Because I imagine you had a lot of data, right?
Yeah.
And so how do you process through that? Like, how do you put it into a format that's easy for you to understand and easy for you to make some conclusions based on it?
Yeah, firstly, it was time series data. So I have to convert it to frequency domain. So I took the FFT of the thickness. So it was much easier to interpret this data. Do you hear me?
Yes, we do.
Sorry, I had my microphone off when I was trying to respond to you. Because I wanted to make sure that there was no feedback. So you said it was time series data initially, and you had to convert it using an FFT. Is that right?
Right. Yeah.
Yeah. And so, like, how much, like, in terms of like how many sources and how many I'm assuming you're dealing with audio files and processing those, right?
Right. Yeah.
Yeah. And so, what would the format then look like after you take all of that?
Format, file format. Are you asking file format or?
Well, like, I guess I maybe should have prepped you more. I didn't prep anybody. I'm gonna call on you guys at random here, but but I'm thinking, like, if you were to present this to a paper, because I don't understand audio files. I wouldn't understand how to look at an audio waveform. So how would you present this into a paper format? Like, if you were publishing this into a journal or a conference, so that those reading the paper and those viewing the presentation would be able to understand, what you learned from the data that you received? Does that make sense?
Actually, yeah, makes sense. So my recordings, the recordings I took like 8 hours or 10 hours long. So I can't represent that much data in one figure. So it was much easier to sample 1 minute samples to represent the data in the paper. So for time series section, I only this long time series data to compare uh, the audios taken from two different microphones. Then I present the frequency response of these audio signals. So it was much easier to compare in this because there was times it is mostly zero noise and zero bowel mobility. So I took the time series that has vowel sounds and noises to represent. If you are asking that, I don't know.
Yeah, no, that sounds about right, because one of the parts about this whole data analysis is oftentimes, well, especially as we start doing more and more computer-based experimentation and system based and gosh, and even now where we have all this uh, parallel processing, having these server farms and parallel processors that are working on these simulations and problems, that there's just huge amounts of data that then need to be put into a format that we can understand it, and so that we can make logical, meaningful conclusions based on it. Uh, one of the things that that I noticed here in the very first bullet as I was looking through some of the material for this particular lecture, this concept of editing was the very first one that came up, and as I'm reading through it, and it's talking about kind of like detecting errors and correcting omissions. Now, especially as it's talking about um, uh, in a survey type situation where you know if a user, if a subject in performing a survey misspells a word, we can write the correct spelling or something like I think that's some of what it's talking about in terms of editing. But is it is there any editing that may need to be done for our own data for a system processing? I think about when I think about this in terms of like misspelled words and stuff like this, I think about Seth's research, for example, where his is taking the abstracts of these different articles and trying to make a best selection uh, for a journal to submit it to. And you know, I wonder, Seth, what what if a misspelled word in an abstract? What if that changed something about the vectorization process of how to do that? Like, would you edit the abstract text in order to get a better understanding of what the abstract's intention was? Because I imagine the paper reviewers would be able to look at an abstract that had a misspelled word in it and be able to understand that, right? And understand, oh, this is a misspelled word, and their minds would replace it with the correct word, right? But our systems can't do that automatically without us telling them, can it?
So, well, obviously there is spell correction, but I don't think I would do that to the data because I'm not sure how that would affect the results. I might do that for um, my own curiosity or something, but I don't think I would actually put results from modifying abstracts like that into a paper. I would leave it as is.
Okay.
Also, there would be I think it would be a lot of effort to supervise, to ensure that spell correction was done properly. If you've ever used spell correction, like the autocorrect on your phone, sometimes it doesn't do what you think it's supposed to do. So
I absolutely understand that about the autocorrect. In fact, actually, I'm gonna joke on my wife here just for a moment, because she has typed in the word with incorrectly so many times that now her phone autocorrects anytime she writes the word with to WIRH. Which is don't, and you guys, I know this is being recorded, but she won't watch this, so you're not allowed to tell her that I threw her under the bus in the middle of class. But that is something that I thought about when I was thinking about editing. Is there, and I guess maybe this this might be partially an ethical thing, but is that, when we think about editing errors that are made in a survey, or editing the nature of data that's collected, editing specifics about the data that's collected, if our intention is to make it more accurate and more correct, is that a problem? Is there something ethically wrong with changing the details of data to make it more accurate? And what level? Yeah, go ahead, Seth.
So I think that's a kind of a complicated thing. That's why they have data science. You have to understand what you can correct and what you can't correct. And there's been a lot of issues recently with this being done incorrectly, leading to bad data sets, leading to models that don't work properly. So it's a big issue, and you have to understand like the complicated details of when to do the correction, when not to.
Mm-hmm. Yeah. Yeah, I would definitely think that it can be very complicated, because we want to have accuracy, but we also want to be ethical at the same time. So I won't spend too much time on that. So then there's also some other processing and how to analyze the data bullet points here in terms of classification according to qualitative versus quantitative. I think, I mistabbed this apparently. Yeah. Okay. Whoop. So qualitative being, what something descriptive, quantitative, being something more concrete, more numerical in nature. So one of the things that they also talked about here in the text is talking about tabulation. And tabulation can be used for being able to put data into a table format, or some kind of concise, logical way, right? Something where we can tabulate the data and be able to have a broad understanding. Could be the basis for a figure or a table, something like that. Because again, we've talked about this with both Erdinch and Seth's work and what they're doing, and they have just so much source data. And Melly, I've also had you talk about your work as well, where there's just so much of data, but we need to be able to put it into a concise format where we can make some logical conclusions without having to look at each piece of data one by one. All right. So I imagine, like, for going back to Seth, that when, for example, yours for the testing set, you trained using vectorized abstracts and what journal they ended up in. Then you took, for the testing purposes, you took an abstract and that the system didn't know which journal it went into, and you had it make a prediction, and then you checked how often did it make a correct prediction, right?
Yes, that's right. In the traditional way, you train on the data, and then with the test, it's data that has not been seen before, so that you can see how well the model generalizes. So I had several different metrics for determining the correct prediction. That's just details.
Right. There was a question I was going to ask you in that. So how do you determine what level of what threshold? So, for example, we went through some different ideas. What we first, top 5, top 10, that kind of thing. How do you decide on that? Like, how does someone decide? Okay, this is a good place for it to end up in. Like,
so for those metrics, the details of those, the top 1 accuracy means that it's correct on the first prediction. That's like a standard traditional accuracy they would think of in any situation. And then I also use like top 10 because it's supposed to be for recommendation. So when you get a recommendation, generally for these kind of things, you want more than 1 recommendation. And 10 seemed like a easy to handle number. Like if you go to like Google Scholar and you type in a topic, may give you thousands of results, but it'll be maybe 10 or 25 on 1 page. And so it's like this when you get recommendations. That's why I chose 10. But I looked at all of them, how the accuracy changed according to how many recommendations were given, and found that the top 5 gave the best accuracy, and then including more did not significantly increase the accuracy.
Which that actually leads me into the following slide. The idea that one of the problems is your percentages. So you said it improved the accuracy. What for your particular study? What was considered a good accuracy? Like what's your threshold for that?
So I considered a threshold of about 80% accuracy, and I found that within the top 5, the model would predict the correct publication being somewhere in the top 5. So it may not be the first one; it might be the second one. And so if we consider the top 5, they would get about 80-ish% accuracy. And then if we included another one, top 6, it might go up to like 80.05 or something like this. So adding more did not significantly increase the likelihood of getting a correct prediction. That was the percentages.
So you're saying 100% is not what you're shooting for?
Well, that would be ideal, but not reasonable.
Yeah. I think running across problems today in the health community because things are not 100%, right? Yeah. So, and that is one of those things that can be very difficult in terms of understanding percentages as well. Because the reason why this is under the slide of the problems in processing is you might think, wait, why is percentages a problem? Sometimes they can be confusing, especially if certain aspects of, I'm going to find a video about this because there was a video I watched few months ago that would really help with this discussion. There was anyway, if two sets are not the same size, we can't just add and averages. We can't just average their percentages together. They can be confusing if they are not understood well by the people who are reading them. So we probably need to make sure that when we use them, we make sure that it's clear what they mean. There was a meme I saw a while back about hand washing that talked about the problem with hand washing, and it was like something like, it said something like 48% of women and 30-something% of men wash their hands, and some person made a comment on it. Well, that's 80-something%, so that's not too bad. But they were just adding them together. So anyway, the part of the reason why the percentages, we can't just throw out a number, throw a percentage out there and expect that our reader are going to understand what that means. All right, so we do need to make sure that we use percentages in our reporting and in our data collection in such a way that it makes sense to what we're trying to understand. They do talk about the don't know responses. Again, this has a lot to do with, again, like I said, a lot of the text for this is really heavy on personal surveys and people's responses to things, people's responses for this type of research. And the don't know response could be because the subject did not respond, or was confused, or either didn't answer or did not answer a question that makes sense in light of what the question was. It could be a don't know response could be similar in our other examples as trying to think of an example based on what you guys have said. Well, like Melly, for example, in your research regarding analyzing the eye, right? What if we threw a picture of something that wasn't an eye in there, or what if we threw a picture of something that was a non-human eye? What would happen in your research? Like, did you guys do that? Did you guys try that at all, just to see what would happen?
Actually, I didn't do that, but I think that would be considered as a noise in data, and it's sometimes used to prevent overfitting in the neural networks case. But if you want to get the best results, I think you shouldn't put any other animal's eye, or the random image of a car, for example. That would somehow reduce the performance of the network.
Right. Yeah, so I was just trying to think of an example of something that would be kind of like a don't know. In other words, it's a in this case it would be a response that doesn't make sense. A true don't know would be if the subject actually wrote, "I don't know the answer to this question," or I don't. It's like, don't, literally, like Seth says, don't know. Which my guess is that in some of what we are talking about here, Seth, for your example, like you're not going to get the response, "I don't know where this abstract should go." All right, it's going to pick something, right? It's going to pick one of the journals in your set, right?
Well, generally with these neural network classifiers, if you get a near uniform distribution, that's equivalent to the model saying that it doesn't know. So if you have 10 classes and it gives the softmax output of 0.1 for all of them, it's basically the model saying it doesn't know.
Okay. Did that happen?
Not in this case, but I saw it happen in the MNIST data set when I was first starting to learn about these.
Oh, okay. All right. Let me see. Let me see if there's anything else in here that specifically jumped out at me that I wanted to go over. Yeah. So and then there's the broad general, this kind of diagrammatic way that we can view the analysis of data. You know, is how to process the data, how to prepare it for the analysis. Again, you know, a lot of this has to do with getting it ready to be able to be understood by us, because you know, I imagine that, you know, as we've talked about here, that you guys used a lot of automated systems. The three of you who have talked so far just now, Seth, Erdinch, and Millie, that you guys use a lot of automated systems to prepare the data for you guys to view it and analyze it and understand it, right? Like you guys didn't by hand go through one by one and see the output on each, Millie, in your case, image of an eye, Erdinch, audio files, and Seth, you know, the vectorization of, you used an automated tool to do the vectorization of an abstract, right?
Yes, I did, but I also looked at the actual vectorization output, but not all of them, just a few samples, just to get an idea of what was going on.
Right, because to do it for all of them would have taken way too much time on your part to be able to get anything done, right?
With 250,000 of them, so yeah.
I guess you didn't want to work weekends. It's a joke. All right. So yeah, so that's all, you getting that data in a format that then we can read to be able to make a decent analysis, and then once we have that data processed and into a format that we can make, there's all these different methodologies for actually analyzing the data in terms of like regression testing and modeling and stuff like that. You know, one of the things that I did look into and I wanted to have a short discussion on as we're getting close to the end of this first hour was the idea of how to understand variables, and specifically how a dependent variable might respond to an independent variable. So how do we change an independent variable and test its impact on a dependent variable? So so any of you who have talked, or any of the others who haven't spoken yet, in terms of how to say, okay, what was my independent variable, my dependent variable, what did I, how did I change independent variable values to make things change for the dependent variable, and how did I test to see what impact it had? Because as far as I understand, based on my understanding of, the whole independent variable, dependent variable relationship, all three of you who have spoken so far had things that you could try to modify on the independent side and see how it impacted the dependent side. And so why don't one of you, or one of the ones who hasn't spoken yet, kind of talk through how do you analyze, or how did you analyze changing something on the independent side, changing something for an independent variable and seeing how it impacted the dependent side?
I varied one variable at a time. So I had like a bunch of different independent variables, and I would only change one at a time to see the effect. If I changed more than one at a time, I may not be able to determine which one had which effect.
Right. That would make sense. So you had multiple correlations, right? So you had not just a simple one-to-one, one independent, one dependent variable. You had multiple variables, and you kind of changed one at a time to try to see how particularly one change would impact another, right?
Yeah, at least like 20 different independent variables. So I also had to use some previous knowledge as to what would be good values to use for some of those independent variables as a starting point.
So with 20 independent variables, I'm assuming you couldn't, I mean, even if you had two values for each, I mean, that's 2 to the 20th possible combinations, right? So how did you choose which ones that you would actually manipulate?
Well, as I said, I used previous knowledge of the system overall to determine which ones to change. Some of them I didn't change at all. I just used some understanding of what's happening to select the value, and then went with that. And then for the others, I would change one at a time, but within a range that was based on previous knowledge.
Okay. So how many did you end up manipulating? How many of your independent variables did you end up manipulating over the course of the study?
No, I don't know exactly how many there were, but if there were like 20 variables, I would have manipulated maybe 15.
Oh, wow. Okay. That's a lot. Mhm. So what about anyone else, either Erdinch, Melly, or anyone else who hasn't spoken? What would be an example of an independent variable, dependent variable relationship that you studied in your research?
Well, in my graduation thesis, I did work with some quaternic numbers. I did work with quaternions, but when I train a model with those quaternion numbers, so there was 4 different attributes coming from quaternions. When I test them, the scores were not really good. Then I transformed them to vectors, and then I did a test, and the scores were better. Then I checked the attributes, like scores, with some algorithms. Like there are some algorithms that will say that will give us the importance of attributes. So when I check them for both vectors and quaternion numbers, I saw that vectors were vectoric, like numbers were performing much better than the quaternic numbers. So I decided to change from quaternic numbers to vectors. That's how I decided to do it.
Cool. So you changed the nature of how. So that was more of a changing the nature of how the data was formatted?
Yeah, like I was going to use quaternions, and those vectors are formed from the quaternions. So the nature of the data didn't really change, but it just, like, the form of it just was just something else, but it was related.
Okay. Anyone else care to share, as well as kind of maybe an example of an independent variable, dependent variable that you would need to that you were testing for? Because like Seth gave us kind of all of the he gave us a count of how many variables he was testing, but maybe a particular example on how to choose which variable could be manipulated. A guesstimation. Do they have a Turkish word for that? A guesstimation? I don't even know what the Turkish for guess or estimation is. Any, I don't know either one of those. No. Okay. All right. So I learned a Turkish word today. Thank you, Melly. Tahmin. Okay. So now if you just give me a estimation, then we can try to see if we can put them together. All right, maybe I'll go look it up during our break. Okay, so I guess we're, estimation time. All right, yeah, let's go, yeah. Tahmin. Okay, we'll go with that. Thank you, Melly. All right. We're just making up Turkish words today. All right. Well, okay. I gotta let my dog out. So let's take a break now, and we will come back in 10 minutes. All right. Thanks, guys.